Hello, we have already discussed with side angle, side criteria, congruency criteria. Herein we take up further congruency rules. The first one here I'm taking up will be ASA congruency. Congruency rule. To do so, I would rather like to first write down the theorem which says two triangles, kindly take this short forms. Two triangles are congruent if two angles and the included side, that's the most important part, not only any side, it has to be the included side of one triangle are equal to two angles and the included side of other triangle. That this we can take up with will be explained more better when we take up questions. So the next one will be AAS congruency. The application will help us make the statements be understood better. AAS criteria says if any two pairs of angles and one pair of corresponding sides are equal, then the two triangles will be congruent. Then the two triangles will be congruent. Let us now take up few questions which might be either on this ASA or AAS rule. I first draw a figure. This is one of the very simple application though. In this figure, it says the diagonal, I write it down, it says in this figure the diagonal AC, that means this has to be AC, this is given BD. Diagonal AC of quadrilateral ABCD, it bisects the angles A and C. We have to prove that AB is equal to AD and CB will be equal to CD. And this can only be done when we prove the congruency of the two given triangles, because then by AB is AD and CB is equal to CD, we can be the corresponding part of the congruent triangle. So let us prove the congruency of these two triangles. So in triangle this and this, so I write in triangle ABC and triangle ADC, what all are equal. Now as because AC is bisecting A and B, so this will be equal to this and this will be equal to this. So we can write angle BAC is equal to angle DAC. That's given. At the same time, angle BCA is equal to angle DCA. That's also given, being bisectors. And if you see the line AC, this line AC is common in both of them. So I can write AC is common, or you write AC is equal to AC. So this is the side included in the two triangles which are equal. Thereby we are applying ASA congruency condition. Conditioning criterions as well, thereby making triangle ABC congruent to triangle ADC. When these two are congruent, by CPCT the sides will be equal. So BA will be equal to DA and CB will be equal to CD, and here you can write CPCT. Okay. Now we move on to take up few more questions. I draw up a figure again. Just keep up. It takes a couple of minutes only. Just 1 sec more to mark them. In this figure it says angle BCD is equal to angle ACD and angle ACB is equal to angle BDA. We have to prove that AD is equal to BC and angle A is equal to angle B. Angle A is equal to angle B. So we have to prove this one, AD and BC. So in that case we have to prove, if I can take, see in these two triangles, if I am taking ACD and BCD, ADC and BCD triangles, CD remains common. So I need to have any more angle to be equal, because BCD, that's given. This is given. BCD, ACD, BCD is equal to, I think I made a mistake. I don't think BCD will be equal to ACD. No, it's given BCD is equal to ADC. Okay, so these two are equal, and then it says ACB, this angle is equal to BDA, this angle. That will make ACD as the whole angle to be equal to BDC. Yeah. What we can do now is we write angle BCD is equal to angle ADC. Also we know that ACB is equal to BDA. Now if we add these two, BCD plus ACB makes ACD angle equal to angle BDC. So you can add this name, maybe equation A1, this might be equation 2. Here you can write it is adding equation 1 and equation 2. We get ACD is equal to angle BDC. Now if I consider the two triangles which I was kind of thinking of, that is triangle ACD and triangle BDC, what do we get? We already have got ACD equals BDC. I said already that CD is equal to kind of CD because that's common. And also ADC, given the small two red ones, okay, ADC given to be equal to BCD, these two. So this by ASA congruency rule we prove the congruency of these two triangles. Once you prove the congruency of these two triangles by CPCT, AD one side equals BC. Similarly, angle A will also be equal to angle B. This is both by CPCT. We'll now take up one more question. What do you suggest? I give you one. Let me just draw one figure. This is named as A, this is B. This point is C, this is D, and that's E. In this figure it says AC is equal to BC. Okay. It also tells us that DCA is equal to angle ECB. These two are equal. More information given says DBC equals EAC. We have to prove that the triangles, so prove triangle DBC is equal to, is congruent to triangle EAC. And there are subsequently few more things to be proved, but that can also always be derived by once we prove the congruency by CPCT. Now it is given in these two triangles AC equals BC, that is one side equality. We also have been given angle DBC, okay, angle DBC is equal to angle EAC, but we need one more angle to be proved equal. Now if I need to prove this part of the whole angle and along this part of the whole angle to be equal, because I have already taken the equality of these two angles, I have taken up this side, so there has to be this whole angle of one triangle to be equal to the other of the same, this angle. So we are now trying to prove DCB equal. Okay, yeah. Now in this question it was given to us that DCA is equal to ECB. DCA, no, is it so? Yeah, DCA is given to be equal to ECB. Now if I add this common part which is ECD, this common part, I'll use some other color. ECB is a common part. Now I add DCA with not ECB, it is ECD, along with ECB with ECD. So DCA plus ECD makes the whole thing as ECA. The angle which I had marked and wanted to prove equal, this one, will now be equal to DCB of the other triangle. So I'll write it here below as I'm writing DBC, so I'll write DCB is equal to EAC. Now it is application of actually ASA criteria which has proved the congruency of the two given triangles. We'll take up more questions on AAS in next few sessions. Thank you.